The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello children, welcome back to the physics class. I hope you all are fine. Do your work on time and study well. Okay, and take care of your health. Drink plenty of water as it is very hot now. Clear? In the previous class, we have discussed on transverse waves, longitudinal waves and also on sound. And what are the factors influencing the speed of sound? Today we are going to discuss yet another phenomena of sound. You have already studied about reflection of light in your 8th standard, isn't it? What is reflection of light? That is, when light falls on a smooth surface, what happens? It bounces back. Isn't it? This bouncing back of light is known as reflection. Whether sound undergoes reflection? Let us see. Look at this figure. Here you can see two PVC pipes are arranged in a particular manner. And there is a glass plate also. Isn't it? This glass plate in a cross side, we have PVC pipe A and B such that both the one end of the pipes is touching the glass plate. This pipes in the end this glass plate touch. Clear? What we have done, there is a clock kept near to the pipe A. So there will be a tick tick sound coming from the clock, isn't it? So what happens is the sound passes through this pipe A and what happens? It goes and hits the glass plate, which is very smooth. As a result, what happens? The sound undergoes reflection. Okay, and when we keep our ear near to this pipe B, we can hear the sound very clearly. Okay, that is the tick tick sound. We glass plate hit it, reflective. And this reflected sound passes through the pipe B, and if we keep our ear near to this pipe B, the sound will be heard more clearly. This is because of the reflection of sound. Now, let me ask you one thing. Does sound from a source reach the listener only directly, or whether there is any chance of reflected rays getting reflected again? See, look at this figure. Here you can see a girl is inside a room, and what happens there? The sound, whether it is getting reflected only once? No, isn't it? The sound gets reflected repeatedly from different objects like walls, ceilings, floor, etc. So here what happens? The sound gets repeatedly reflected from different objects. Such type of reflection is known as multiple reflection. Clear? So what is multiple reflection? Sound gets reflected repeatedly from different objects. This reflection is known as multiple reflection. That is, one sound one pravasham maatrame reflect cheyallu. Okay, that is, we room inagateke povunna time il walls il thattittu reflect cheyam, adhe sound nere poi floor il thatti reflect cheyam. Angane oru sound thanne koodal thavana onnil koodal thavana reflect cheyanulla chances undu. Such a reflection is known as multiple reflection. And there are certain situations where this multiple reflection of sound is made use of. Some devices like megaphones, horns, and some musical instruments like shahnaai, trumpet, etc. They are designed in such a way that the sound produced gets reflected repeatedly, or it undergoes multiple reflection without spreading anywhere, and at last what happens, you can see a conical shaped end. Okay, through that end the sound comes out. Is it clear? That is, the devices like megaphone, horns, or musical instruments like shahnaai, trumpet, etc. that allows multiple reflection of sound to travel in a certain direction, and through the conical end the sound comes out. There multiple reflection is taking place. Clear? Multiple reflection നടക്കുന്നത് കൊണ്ടാണ് നമുക്ക് ആ സൗണ്ട് കുറച്ചുകൂടെ ലൗഡർ ആയിട്ട് നന്നായിട്ട് കേൾക്കാൻ പറ്റുന്നത്. And another device is stethoscope. അല്ലേ? What is the use of that? To know about our heartbeats. അല്ലേ? There is a diaphragm. അപ്പോൾ നമ്മളത് ഹാർട്ടിൽ വെക്കുമ്പോൾ that sound undergoes multiple reflection. As a result, the doctor is able to hear the sound more clearly. And when you notice certain halls, the ceilings of the halls are given curvature. This allows multiple reflection and the sound gets spread everywhere in the hall. Okay, and soundboards of some musical instruments happens, which is kept behind the screen, allows multiple reflection. As a result, the sound spreads everywhere in the hall. Okay, cinema theaterലൊക്കെ ഈ സൗണ്ട് ബോർഡ്സ് വെക്കുന്നത് മൾട്ടിപ്പിൾ റിഫ്ലക്ഷൻ നടന്നിട്ട് എല്ലായിടത്തേക്കും കറക്റ്റ് ആയിട്ട് സൗണ്ട് കേൾക്കാനാണ്. Clear? The curved shaped boards placed behind the screen allows multiple reflection, and as a result the sound spreads everywhere in the hall. And the boards in guitar, violin, etc. also act as sound boards. Let's move on to the next topic. Have you ever felt any difference in the sound produced in an empty room, especially a new built house? അതായത് കൺസ്ട്രക്ഷൻ നടന്നുകൊണ്ടിരിക്കുന്ന അല്ലെങ്കിൽ ഏകദേശം പൂർത്തിയായ ഒരു വീട്ടിൽ പോയിട്ട് നമ്മൾ സൗണ്ട് ഇടുന്ന ടൈമിൽ there is a difference in the sound. Have you ever felt that? What difference you have noticed? You experience a booming effect. ഒന്ന് മുഴങ്ങുന്ന പോലത്തെ ഒരു സൗണ്ട് കേൾക്കും അല്ലേ? This is known as reverberation. Reverberation. Okay, so what is reverberation? It is the booming effect of sound caused as a result of the multiple reflection of sound. Okay, അതായത് when the sound is produced, what happens? Already we have studied, multiple reflection takes place from walls, ceilings, floors, etc. Okay, and these reflected sound, whether it will reach the listener at the same time, അതായത് ഈ ഒരു സൗണ്ട് ഒന്നിൽ കൂടുതൽ തവണ ഓരോരോ പ്ലേസസിൽ പോയിട്ട് റിഫ്ലക്ഷൻ നടക്കുകയാണ് അല്ലേ? Whether this reflected sound reach the listener at the same time? No. Okay, the sound which reaches the listener will retain in the ear for 1/10 seconds. Okay, അതായത് നമ്മൾ കേൾക്കുന്ന ഒരു സൗണ്ട് നമ്മുടെ ഇയറിൽ 1/10 seconds റീറ്റെയിൻ ചെയ്ത് നിൽക്കും. ഓക്കെ, അതിന് മുന്നേ തന്നെ അടുത്ത സൗണ്ടുകൾ വരുന്ന സമയത്താണ് the overall effect is felt, and as a result that booming effect is experienced. This is known as reverberation, and that property is known as persistence of audibility. Persistence of audibility. So what is persistence of audibility? That is the sound which we hear retain in our ear for 1/10 seconds. Okay, within this time, if another sound comes, what happens? That simultaneous effect of sound is felt. That is known as persistence of audibility. The sensation of hearing produced by a sound is retained for a period of 1/10 seconds. This characteristics of the ear is the persistence of audibility. If another sound reaches the ear within 0.1 second or this 1/10 second, one can hear both the sound simultaneously. So reverberation is the persistence of sound as a result of multiple reflection. So understood what is reverberation? It is the persistence of sound as a result of multiple reflection. As a result, that booming effect is felt. This boom of sound is known as reverberation. Now, you might have noticed when you go for certain picnics and all, when we make a sound, especially in the hilly areas, when we make the sound, that sound gets reflected back. Isn't it? അതായത് ഹില്ലി ഏരിയാസിലൊക്കെ പോയിട്ട് നമ്മളിപ്പോൾ എന്തെങ്കിലും വിളിച്ചു കഴിഞ്ഞാൽ ആ സൗണ്ട് ഇത്തിരി നേരം കഴിഞ്ഞതും റിഫ്ലക്ട് ചെയ്ത് നമുക്ക് കേൾക്കാൻ പറ്റും അല്ലേ? വാട്ട് വിൽ യു കോൾ ദാറ്റ് ഫിനോമിന? യെസ്, എക്കോ. Okay, so there should be a minimum distance between the object and the reflecting surface to hear the first sound clearly after reflection. Okay, so how can you calculate this minimum distance? Let's see. Already we know the speed of light, or the formula to calculate speed is equal to distance by time. Minimum distance between the listener and the reflecting surface to hear the echo. Okay, so from this we can write, therefore D is equal to speed into time, V into T. And what is the speed of sound in air? Speed of sound in air is speed of sound in air is equal to 340 meter per second. Okay, and we have already studied that the sound which reaches our ear persists for a time of 1/10 second. So we can time as 1/10 second. So how will you calculate distance? Distance D is equal to speed 340 into 1/10. So what happens? It is 34 meter. So the total distance between the reflecting surface and the object that produces sound, the total distance is 34 meter. So what will be the distance to the reflecting surface from the object? It will be 17 meter. Is it clear? അതായത് ടോട്ടൽ ഡിസ്റ്റൻസ്, അതായത് ആ ഒബ്ജക്റ്റിൽ തട്ടി സൗണ്ട് ആ ഒബ്ജക്റ്റിൽ തട്ടി തിരിച്ച് നമ്മുടെ അടുത്തേക്ക് എത്തുന്ന ടൈമാണ് എത്ര പറഞ്ഞത്? ടൈമല്ല, ഡിസ്റ്റൻസ് ആണ് 34 മീറ്റർ. സോ വാട്ട് വിൽ ബി ദ ഡിസ്റ്റൻസ് ടു ദ റിഫ്ലക്റ്റിംഗ് സർഫസ്? ഇറ്റ് വിൽ ബി 17 മീറ്റർ. Isn't it? So to hear the echo, the minimum distance should be 17 meter, or it should be more than 17 meter. Clear? So what is echo? Echo is the phenomena of hearing the sound after hearing our original sound. Echo is the phenomena of hearing a sound by reflection from a surface or obstacle after hearing the original sound. അതായത് നമ്മുടെ ഒറിജിനൽ സൗണ്ട് കേട്ട ശേഷം വീണ്ടും ആ റിഫ്ലക്റ്റഡ് സൗണ്ട് കേൾക്കുന്നതാണ് എക്കോ. Okay, so the distance for hearing the echo, it should be more than 17 meter. Okay, so shall we do one problem? See here, what should be the minimum distance between the source and the reflecting surface if the echo were to be heard while under water? Speed of sound in water is 1482 meter per second. So speed is given, isn't it? So we can represent it as V. V is equal to 1482 meter per second. And what is the time? Time T is equal to 1/10 seconds. So we have to calculate the distance. We know distance D is equal to speed into time, which is equal to 1482 into 1/10, which is equal to 148.2. Okay, 148.2 meter. Okay, this is the total distance. So what will be the distance to the reflecting surface? So the distance to the reflecting surface will be 148.2 divided by 2, which is equal to 74.1 meter. So the distance to the reflecting surface is 74.1 meter. Is it clear how to do the problem? So here speed is given and time you have already studied, it is 1 by 10 seconds. So velocity into time or speed into time is distance. So we got the answer as 148.2, which is the total distance. The distance to the reflecting surface will be half of that, which is equal to 74.1 meter. Clear? Now let me ask you one question. You all have gone to cinema theaters, right? What is the speciality of the walls there? Or when you go to certain big halls or cinema theaters, there is a speciality in the walls. Have you noticed that? The walls will be very rough. Why the walls are made rough? സ്മൂത്ത് ആയിരിക്കില്ല, നമ്മുടെ വീട്ടിലെ പോലെയൊന്നും സ്മൂത്ത് ആയിരിക്കില്ല, അത് റഫായിട്ടായിരിക്കും ഉണ്ടാവുക. എന്തിനാണ് അങ്ങനെ റഫാക്കി വെച്ചിരിക്കുന്നത്? നമ്മൾ ഓൾറെഡി പറഞ്ഞു, what happens? Sound undergoes multiple reflection, isn't it? So to avoid this multiple reflection of sound, the walls are made rough. Okay, the walls or the floors etc. will be made rough. So what happens if there is multiple reflection of sound? Will you be able to hear the sound more clearly? No, isn't it? The sound will not be clear. So to make the sound more clear, the walls are made rough. Okay, that is, it is done to avoid the multiple reflection of sound. So what all things can be done again? Idu maatrano? Alla, namukku endakku cheyam? You can use curtains. Okay, curtains use ചെയ്തു കഴിഞ്ഞാൽ നമുക്ക് റിഫ്ലക്ഷൻ കുറയ്ക്കാൻ പറ്റും. അതേപോലെ cushion seats. If you are using cushion seats, this multiple reflection of sound can be reduced. Okay, അതേപോലെ ceilings ഒക്കെ thermocol വെച്ചിട്ടൊക്കെ നമ്മൾ ഡെക്കറേറ്റ് ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ multiple reflection of sound can be reduced. Okay, so these all things can be done to reduce the multiple reflection or to make the sound more clear. And there is a branch of science which deals with the construction of buildings to ensure maximum audibility, that is known as acoustics of buildings. Okay, acoustics of buildings. Acoustics of buildings. Okay, so what is this acoustics of buildings? Acoustics of buildings is a branch of science that deals with the conditions to be fulfilled in the construction of a building for clear audibility. Okay, അതായത് കറക്റ്റ് ആയിട്ട് ക്ലിയർ ആയിട്ട് കേൾക്കാൻ വേണ്ടിയിട്ട് നമ്മൾ എന്തൊക്കെ കണ്ടീഷൻസ് ഫുൾഫിൽ ചെയ്യണം ഒരു ബിൽഡിംഗ് കെട്ടുമ്പോൾ, അതൊക്കെയാണ് നമ്മൾ ഈ ബ്രാഞ്ച് ഓഫ് സയൻസിൽ കൂടെ ഉദ്ദേശിക്കുന്നത്. ക്ലിയർ ആയോ? Now look at this picture. Here you can see a cathedral in London where the sound is reflected, or it's a best example to prove that sound gets reflected. Okay, and this is known as the whispering gallery. Even if we make a very small sound, what happens? It gets, or അതിങ്ങനെ എന്താ പറയുക, ആ കത്തീഡ്രൽ മുഴങ്ങി കേൾക്കും. വളരെ കുറച്ച് സൗണ്ട് ആണെങ്കിലും നല്ല സൗണ്ടിൽ നമുക്കത് കേൾക്കാൻ പറ്റും. ഇറ്റ് ഈസ് നോൺ ആസ് ദി വിസ്പറിംഗ് ഗാലറി. Okay, even if we make a very small sound, the sound gets reflected. As a result, the sound will be heard louder. And this is due to the multiple reflection of sound by the circular walls. So what all things we have discussed today? We have discussed on reflection of sound, multiple reflection, reverberation, echo, and acoustics of buildings. So go through the class. If you have any doubts, you can contact me. See you all in the next class with a new topic.